Hi everyone, so the game I've chosen is a physics game which helps students to understand Newton's second law of motion, F is equal to ma. That is the relationship between force, mass, and acceleration to describe and predict an object's motion. So the aim of the game is that students are in control of a spacecraft where they have a control panel. The control panel has force settings, a velocity radar, an acceleration bar, and a velocity time graph. The velocity time graph will help students to see the motion of the object in real time in a mathematical way where the gradient of the line itself is in correspondence with the acceleration. So the first task tells us that the spacecraft is carrying no cargo and the mass is 100 kilograms. That means the mass is constant. Students can apply their prior knowledge of physics laws and of motion to understand what they're trying to tell us in that first sentence. So then it tells us that the engine needs to make the craft accelerate at a constant 5 meters per second per second. Students know that the only setting they can change is actually the force setting, so they can go ahead and try out different settings until they get the desired acceleration. As they can see, they've now reached 5 as they wanted, and here's the motion in real time. Moving on to the next task. It tells us that the spacecraft has taken on cargo and the total mass has increased by 100 kilograms and is now 200 kilograms. However, the engine still needs to accelerate to a constant 5 meters per second per second. So students know that they can only control the force setting. At 1, the acceleration reads 2.5 meters per second per second. However, the task tells us that needs to get to 5. Students can change that to 2, and now they see that it's reached 5. And how the motion has changed in real time, as you can see the changes there, and then the constant acceleration. By the end of the game, students will understand the relationship between the variables force, mass, and acceleration, that there is a positive correlation between force and acceleration, whereas force increases, so does acceleration, and that there is a negative correlation between mass and acceleration, whereas mass increases, acceleration decreases. That is to understand the application of the theory F is equal to ma and how that can be used to describe and predict the object's motion.